Here are two separate instances where multiplication is involved with imaginary numbers, including square roots. So in this first example here on the left, we need to distribute the square root of -2 to both of these terms inside the parentheses. And the first one's going to be the square root of -16. And the second one, we can think about, I'm just going to write it out as the square root of -2 times the square root of -5 for right now. We'll get there. Okay, this first one, the square root of -16 is 4i. For this next one, I'm going to break apart. I know that the square root of -2 can be I square root 2, and the square root of -5 can be I square root 5. So moving on to the next line, I know I'm going to have I times I is I squared, and 2 times 5 is 10. So I'm going to end up having 4i, and then I squared, of course, is -1, so it's going to be -1 square root 10. Now when we want to write a complex number out, or write the final answer in black, we want to have the real part, so in this case negative square root 10, which is that -1 square root 10, and then plus that 4i. We want to have the real part first and then the imaginary part or term second. The second problem in blue is a complex number, 10 being the real part and -3i being the imaginary part, and it's being raised to the second power, which a lot of you prefer to write out twice, since we're going to have to multiply two binomials together, and some of you use FOIL to do that. So our first is going to be 10 times 10, which is 100. Our outside terms is 10 times that -3i, which is -30i. Our inside term ends up being the same thing. And our last is -3i times -3i, which is plus 9i squared. So combining like terms, in this next line we're going to have -60i, and then since I squared is -1, it's really plus 9 times -1 or -9. And combining our like terms here, we have 100 minus 9, which is 91 minus 60i.